Okay, for question 10, it is more on your ray diagram. So like I said, for ray diagram, uh, if you are unable to do ray diagram, right, what I suggest you to do, whenever you do ray diagram, just sketch out the rough shape of the ray diagram. So in this case, we know that a real image is formed because you can see that the image is on the other side of the lens. So if that's the case, then on the left side, or find any space, just sketch out the rough shape of the ray diagram. So for me, I always do that, or I should say that when I start, I will always use this. So even if you do not know what is the focal length, it's fine. It's just a dummy shape for you to help you visualize the thing, or the end shape of the things. So once you sketch out the rough shape of the ray diagram, basically you can identify that this is like a dot and line game. So these are the dots that is useful to you. So label them 1, 2, 3, 4, 5, 6, 7. So once you label them, you compare what you have in mind, the default shape, with what the diagram offer you. So you have already 1, you have 2, you have 4, you have 3, you have 6, and 7. So now what you need to do is you just compare what you have and what you should have. And you can quickly see that 4 and 7 can be linked, right? 4 and 7 can be linked. So you can just do 4 and 7, right? Done. What else can be linked? If you look here, 3 and 5, right? But since you do not know where is 5, you can actually see that 3 and 5 is linked, but 3 and 7 is also linked, right? So you can actually do 3 and 7. So 3 and 7. Once you do 3 and 7, you will find that 5 come up, right? Your 5 come up. So once you have all this shape, you can actually erase all this working because it is not allowed huh? Right, so erase this, yeah, and then you just write down what you need. Okay, this is F, right? So I have already F, right? I've already constructed. Oh, I need to construct for all 4 ray. So all the other ray, basically what happens is that it will just converge to the image. So just draw properly with your ruler, yeah. And then last thing is, of course, add in the arrows lah. Okay, done. To find the focal length, basically your focal length is here. So you can actually measure and find out. So in this case, if you are measuring, right? If you are measuring, then just show 1 dp because you are using a ruler. Okay. Okay, then for your part D, object distance, determine how far so here is I need to move my object such that my image will be same size. So unfortunately, this one is memorization. If you want same size, then the object distance must be at 2 times the focal length. So since you already know the focal length over here, you multiply by 2, you will get this. So for part E, what I've done is that I just transfer the diagram here. And now they say that there is now a hole. If there is a hole here, that means the light ray that passes through this place, initially when light go here, it will all converge to your center line, right? This is what will happen. But if there is a hole, then light that goes into the hole will just go straight. That means it won't converge there. But the rest of the ray, like this one, it will still converge at that point. Like this, it will still converge at that point. So meaning that your image, right, will not disappear because of rays like the yellow ray and the green light and the green ray, or even the pink ray. It will still go to the image. So only some of the ray will not converge there. So what happens is that the image will not be will not be as bright as before. So we say that now the image will be dimmer. Will it be not sharp? Well, since the image forms at the same place, right? Because of the yellow ray, the green ray, and the pink ray, it is formed on the same plane. So therefore, it is as sharp as before. This is wrong, right? It will be as sharp as before. Will it be blur? No, it won't be blur because the image distance never shift. Okay. So I think I will continue with question 11 because it is just a sound question. So like I said, this particular wave give you an axis about time. So in my previous video when we recap on wave chapter, we say that when a displacement time graph is given to you, you can actually find the period. So if you look at question 11, this is what a displacement time graph looks like. So now they will tell you basically what this wave is telling you is actually the period. Okay, so now they are asking you to sketch I have to sketch the sound wave that is louder. So when it is louder, it means that the amplitude will be higher. Same pitch means that your frequency will be the same, and if frequency is the same, meaning that your period will be the same. So when you sketch your graph, you should have one graph over here and make sure the amplitude become bigger. So you should cut this point at the same place, then it will go like that. Okay, then after that you just need to duplicate this. Okay, for me of course it's easy. I can use my copy and paste function and I can just put it over here. Okay, it is important for you to take note, same point, I didn't change. Okay, don't shift your wave and you should be able to get the